recording again. Okay, so plan for today, a reminder, show your calculator on quizzes. I think it's Tuesday or Wednesday that we have the test. And show your calculator. That is good, evidence that you're not cheating, and also that know how you're supposed to come up with the numbers that you're getting for your answer. So show calculator, ALA Q&A. So I thought, I was thinking this 3 minutes ago, Aja. There's never a question, but then we end up getting delayed, and then the ALA gets short shrift later. So let's switch it, ALA Q&A, and then you jumped on here saying what you said. So yeah, like you say, let's get to it. Let's go to the questions, and let me find. Should I look for your homework?
Wait, you want me to ask my question first, or you want me to wait till the end?
Since you came in with questions, that you want.
I can wait. It's fine.
No, absolutely. This is the best time to talk about it when it's like on your mind. So let's find those.
The only question I had was in the video. She was explaining. I just needed to add I can't use StatCrunch for the finding like the p-value and stuff.
I'm sure you can.
Because I saw in the most recent videos, like when she was looking for quantitative data, she used StatCrunch, but on like the 7.2 videos, she didn't use StatCrunch at all. So, and I don't have a T80 whatever calculator, so
Yeah,
I couldn't finish my homework.
okay, so let's look at that. And yeah, it shouldn't be a problem to do the homework using StatCrunch. All right, so you said 7.2 homework?
That's the one.
Okay.
But as you can see, my test statistics, I couldn't figure out how to do the p-hat because.
Okay, well let's look at that. So we're testing for proportion.
And on the 7.3 video, she was showing when you're looking for mu that you can use if you go down to I think it was summary stats and then the okay, well, I don't know.
Okay, well we'll talk about testing for mu, but let's see. Testing for proportion, one sample. This is probably summary, but let me.
But see, it gives you for mu and not p. So I didn't know if that was the same thing.
Okay, let's look at the problem. How about that? There's believed 11%. Okay, so this is for proportion. 11% of all Americans are left-handed. So it's believed that we're going to do a test to make sure that's really true. So the alternative hypothesis will be that it's not true. Now, the way they word it's important. Let's see. Does this provide enough evidence to show that students at this college have a higher? So the alternative hypothesis is a greater than, which you have there. Use a 9% level of significance. And what we have are these values. Okay, so P null is 0.11. N is 320. X is 43. Big big N. Okay, sample of 320. Oh, okay. So we don't even need the 33,416, I don't think. Okay, so alpha equals 0.09. Good. Now, the p hat, I mean, you can do that, right? I mean, you're just, in fact, I would just,
I didn't know the formula for that. I couldn't find it, and I didn't know how to figure out p hat. I didn't know
okay,
what that.
all right, fair enough. So p hat is, the formula is just x over n.
Okay, I didn't know that.
Yeah. So 43 over 320, which they probably want a decimal.
No, it said leave it as a fraction, but
Did they? Oh, I'm
Mhm.
like that. Okay, good. Oh yeah, it does say that. Like that. Okay. Then a value of z. Now you can get this with or without, tech, because, well, if you have p hat, right?
Mhm.
Without the p hat, you couldn't have even started this.
Yeah, I couldn't start that part.
Yeah.
So now I think I'll be okay if, because I just didn't know what p hat was and where I got that from. So now that I know how to do it, then I should be okay. Oh, actually, can you go to the next question?
Well, you can get the test stat, but the test stat, it takes one more like step in the problem to figure out the p-value, unless you just get it from StatCrunch or the calculator. So let's see. Sample mean without proportion.
I couldn't find in StatCrunch where you would do proportion. And that's why I said in the video, she didn't show with the proportion. She only showed it with you.
It's got proportion stats. One sample with summary, number of successes is
Oh, so that's
23.
how I would do it.
Yeah, it had to be there because you just don't leave out something like that.
Okay.
320. P is 0.11. That's the hypothesized population proportion. Alternative, it's greater than that. See what we have here. So there's our test stat, and there's our p-value. So with alpha at 0.09, p-value is less than alpha. If the p-value is low, the null must go. So reject the null hypothesis. We don't think it's just 0.11 lefties. All right, so z-stat, yeah, 1.4, 1.39, 36. 1.4, 1.3936. And the p-value is 0.08 and change. And p-value is less than alpha. Less than alpha, which is 0.09. We reject. By the way, that bottom one there is never the answer, except we never accept. It's just reject or no reject. Now, if you reject, then it's only can be because of evidence. You know, if there's not enough evidence, then you just have to say, oh, we can't reject. We fail to reject. So there is sufficient evidence to conclude that the hypothesis of 0.11 lefties is not right. So let's see. Percentage of all students on this campus. To conclude that, I have to see the rest of it, I guess. Percentage of all students from this campus that are left-handed is differs from. No, is more than, because the alternative was strictly greater than. Alternative is a strictly greater than. There. So is more than the 0.11. Make sense, Aja?
Yeah, I got it. Thank you.
Great, you're welcome. Yeah, I mean, I know your question was just about the tech. Any other question?
I didn't understand that question right there, but I'll probably figure it out later. That's why all of them are wrong, because I couldn't figure out what it was asking.
These assumptions? Okay, let's look at that. July 23rd.
Like the numbers I was putting in there, they were saying were wrong, so I don't know what numbers I should have been multiplying together.
Australians. So big picture here. We're going through this phantoms process in doing a hypothesis test for P, the population proportion. So it's already kind of like fuzzy because P, everything's P, right? We got P value, we've got population proportion P, we got P hat, we got probabilities, and they're all P's. So lots of P's, but and what's even more confusing is if we had used, and sometimes this does happen, in literature where for the population proportion, they have capital Greek letter P. That would be probably better because usually for our population parameters, we use Greek letters, mu, sigma, chi-square. And why do we just use a regular letter P for population proportion and then for the sample statistic P hat? But that's what we do. Maybe there's a movement to change that. I do see the Greek letter P for a population proportion. But that's just like adds to the confusion that we use a regular letter, not a Greek letter, for population proportion. So it's not that easy to keep all the P's straight unless you're doing lots of problems. Okay, so phantoms, P is what's the parameter. H is the hypotheses, the null and alternative. A are these assumptions. So, before you can even do anything, you have to, make sure the assumptions are appropriate for the test. Sometimes you can't even run the test because you don't even have the assumptions. And then that's like a problem that you have to, do in the class, and you have to say, cannot run the test. We don't have the right assumptions. There aren't many of those because as educators, we want to see you run the test. Okay, so let's see. Simple random sample size n is taken. There are two categories for each object. So Kozak always makes the comparison here to the binomial experiment. NP greater than 10 and NQ greater than or equal to 10. So those two things have to be true. And then big N, which is sometimes not given, but that's like a population size, greater than or equal to 20 times the little n, which is the sample size. So this question is about the assumptions. Okay, so let's get our N and P, all of our, important values. 47% thought that it would increase. So that's July of 2013. And then they're going to talk about November of 2013. So the July of 2013, I think they're going to let that kind of be a baseline. And so that will be the P of the null hypothesis, P sub null, P null, P sub 0, and that's 0.47. Then later, they were asked again, then we get an X of 448, a little n of 1,000. So P hat is 0.448. Alpha is 0.06. There's a 6% level of significance. So alpha equals 0.06. Is there enough evidence to show the proportion of Australians in November, so that later when they took this sample, who believe unemployment would increase, which is what they were asked earlier, is lower than the proportion of fellow would increase in July. So let's see, H null is that, and then H alternative is that. Assumptions. Qualitative information is collected from each object. What that means is you either think it or you don't about unemployment. So qualitative instead of quantitative information, which is numbers. Here it's you do or you don't. So that's qualitative. Okay, so NP, so we're going to multiply 1,000 times P, which is this P null here. And so that's the P they're talking about there is for the population. If it were for the sample, they would say P hat, but they're not saying P hat. So this thing up here is P, and NP is 1,000 times 0.47, which is 470. Okay, which is greater than or equal to 10. Okay, makes sense on that one, Aja?
Yes, sir.
And then N1 minus P, or NQ, yeah, Kozak always uses 1 minus P. So that's 1,000 times 0.53. That's 1 minus P, 530, which is also greater than or equal to 10. Big N, let's see, they didn't give a big N, did they? There's no big N. So, I mean, it's just Australians. So, you know, every Aussie that could be polled there. So that, it says if no N is given, oh, and I know that there are issues on this one. I've had a lot of students come to me and said, there's no big N given, and I used 1 million the way they said, and then they marked it wrong. But it is supposed to be a million according to their instructions. Now that this is saying they would accept 1 million. Now, is that greater than or equal to 20N? Okay, so according to the assumption that we're supposed to, you know, the thing we're supposed to assume, that's supposed to be 20N, which is 20 times 1,000, or 20,000. And 1 million, 20,000, and 1 million, 1 million is greater than 20,000. So we're okay on that assumption also. Make sense?
Yeah, that makes sense now. Thank you.
My pleasure. And you know how to do the test for P in StatCrunch. Jocelyn, do you use StatCrunch or the calculator? So I feel like doing a calculator one, just because we've done the StatCrunch one, and Aja, I think you're good on that, so maybe we'll do a calculator one. But I'd run StatCrunch again. It seemed like you were about to say something, or maybe it was you were talking to your dog.
No, yeah, I'm okay.
All right. So calculator one. Test for proportion. So stat tests, and yeah, one of the things in Phantoms is, you know, what kind of test are you doing? So that's probably the next one. Let me see if I can get away with doing this. So assumptions, we talked about that. Name, See the N, it's like you're like this acronym. What is the N? Name of the hypothesis test used. Okay. I guess you had to reach to make an acronym that actually works. Name of the hypothesis test used. One proportion z-test. Find the sample stat and the test stat, which we'll get from the calculator. Obtain a p-value, and then if the p-value is less than alpha, we'll reject the null. One sample, one proportion z-test. One proportion z-test. P null is 0.47. X is 448. N is 1,000. The alternative hypothesis is a less than, so we have to go over here and select that. Yeah, I have to get rid of that curve on there. So I just like to do the draw. I just like to see it. I mean, you get the test stat and the p-value either way. So the test stat z is negative 1.3939. The p-value is 0.0817. Let's see. Is that the right problem? Yeah. So there's your value of z, the test stat, and the p-value, which is confusingly they just say p. I try never to do that. Just say, oh, p is. And I know that's what people do. And everyone says p less than alpha, reject, all that. But please, there's so many p's, you got to say p value or p val or pb or something with b in it. But they just say p, but that means p value. And so that's less than alpha, which is point. Oh, wait. Oh, alpha was 0.06. No wonder I was thinking it was the wrong problem. I put the wrong significance level in there. They didn't ask for a significance level. So actually the p-value is not low enough to reject. We're going to fail to reject on this one. That's good that we had one of those. So p-value is not very low. And so it's not going to be less than alpha. Alpha is 0.06. So p-value is, okay, so the p-value, got to make sure you're inputting the right thing. Oh, it's that not equal to sign. That's the problem. You might know, you
Oh
might,
yeah, you have to put, is it less than?
yeah, it's a less than for the alternative. That's why this is exactly double the p-value that they gave us. Because on a two-tailed test, which is what we have when this is a not equal to instead of a greater than or less than, then you have to double the area. And what the area is this area which is in the tail. We've got area in the tail, and we've got area in the other tail because the calculator thinks we want to run a two-tail test. But because of this word here, lower than, and this alternative hypothesis, we have to change the alternative hypothesis to the less than, which is the middle one. I thought I had done that, but okay. That will give us the same z-score, but now a lower p-value. It's still not low enough to save the alternative hypothesis. We are going to fail to reject the null because the p-value just wasn't all that low. So the null doesn't have to go. Since the p-value is greater than the 0.06, which is the significance level alpha, we fail to reject. So there's not enough evidence. When you fail to reject, it's because you don't have enough evidence. You would like to get a lot of evidence and say, reject a null. It's more fun that way. But if you don't have that much evidence, which we don't here, then you can't do it. Non-significant evidence to conclude that the null is wrong, that the null, which is all Australians in that baseline month of July, I see what the way they're structuring the sentence. Okay, we're making a statement about the population parameter P. So it's not going to be about the sample. It's all Australians or all Aussies who are pollable. Signage of. There is not enough evidence to conclude that all Australians well, it's not all Australians. There's that 0.47 of all Australians think that unemployment is going to increase. So, boy, this is very subtle. Got to be careful here. And you have to like compare it to the rest of it. So the null is the equal to, not enough evidence to conclude that 47%, oh yeah, right. The portion of all Australians, the percentage of all Australians that believe unemployment would increase. So we know that we have to be talking about the population there because it says all Australians, and that's the right thing. Is equal to 0.47. Okay, we have a sample which we thought might show that there would be enough evidence to reject that, but there just isn't. Okay, let's go to the ALA. Reject or no reject. We could, it's really two ALAs kind of smashed together. One, it's P reject or no reject. And then there's mu reject or no reject. My favorite is, we haven't done yet, which is rho reject or no reject, which rhymes. Looks like maybe someone's here already with the login 219. So we're going to the ALA from the link in MOM using the name 219, right, Jocelyn?
What was the code again?
The code is, it just populates if you follow the link. So you don't have to worry about the class code. You just use the name 219. So
Okay.
yeah, go there. The code is what it is, and it's the right one if you're following the link 219. So now we've been talking about P. There's no reason why we can't there's no reason why we can't start in the middle with P reject or no reject. Since we're kind of thinking about P, and then we can go back and get mu. As always, I try not to say too much, but just let you, whoever's in the meeting, struggle through it. Talk to each other. Refer to sources like Kozak, whatever. And then I'll jump in if there's something wrong.
Okay, so I know for the P would be the P value.
That is not the P for which we are testing.
Oh. P.
Can y'all see that? Oops. Is that what it's asking?
Yes, that's good on that second focus question. Yeah. And then we have a autobiographical question here up on that third one, which is going to vary for different people depending on what tech they're using. That's the main difference.
I don't get the third question.
So this is kind of what I was asking earlier, Jocelyn, about do you use StatCrunch? Do you use the calculator? And then so just say whichever one you use, and then once you say that, you will say what menus or keystrokes you use for that tech to get the p-value.
Okay.
I'm not sure on StatCrunch how it's computed because you just showed me just now how
Yeah.
to work it in StatCrunch. So I'm not.
Okay. Well, that would be a good place for Jocelyn to work in here. She uses the calculator, so that's perfect. Now, Aja, on that fourth one, we never say accept, and we never say fail to accept either.
Oh, I meant reject. Sorry. I knew we didn't say accept. Let me see. Oops. That's a howler.
So Jocelyn, you were gonna put in keystrokes and menus you go through to get to where you get the p-value.
So basically, I would like say kind of like the steps, so like stat, and then go to test, and then it'll be no 5, which is one prop Z test.
Right. And Aja, you have to get rid of the fail to.
Oh. Oh, okay. Oops.
And you're writing that up, right, Jocelyn? There you go. Stat, one prop. Okay, good.
Then after that, would I just put like calculate? Because I mean, then you'll put the info for
Yeah,
it.
well, yeah, the next thing is just input the values from the problem, and then, yeah.
Calculate.
Just so you're aware, there's another approach called the critical value approach. There's an even other one beyond that called the confidence interval approach. But everyone in stats in this century uses the p-value approach, and we are going to keep it to the p-value approach. But there is this critical value thing, which is what we're alluding to when we say using the p-value approach. Because if you use the critical value approach, you get the same results, but it's just kind of a different, method. So why don't we start with the calculator, Jocelyn, on number 7 there, and then afterward maybe we'll get Aja, yeah, sharing the screen. Oh yeah, she can do that usually. If that's okay.
You want me to do it for 7 or 8?
For 8.
For 8, okay.
So if you've got an eye on Zoom, Jocelyn, you can see I'm doing it also because I don't have an answer key. So I'm just making sure it's what you're putting is right.
So for reject HO, would I put yes? I think it'll be yes.
Why do you think it's yes?
Because wouldn't it be that the p-value is lower than the 0.05?
Exactly. Yes. Ready to share? Acha?
Okay. So for P is 0.06 and it's less than. What do I put for number of successes? Is that the 250?
Um,
Was
let me look at the problem again. This is trying to paste it where I can see it and also what you're doing. So let's see. So, I'm sorry, what was the question?
And number of successes and number of observations.
Okay,
Which number is which? I don't know which.
okay, well, what do you think it is?
Is N the number of successes?
Um, N is the number of observation and X is the number of successes.
I don't do anything else, right?
Let's see, hypothesis test for P. Um, Alternative is a less than. Right. We don't care about a confidence interval. We're not doing that. Yep. Output. Yeah, looks good.
Oh, um do I need to log into the class kick on my laptop?
You know what? Why don't you stop sharing and I'll start sharing and we'll just work like that. And I'll just bounce back and forth with the tech. Or maybe I'll just eyeball it and say, yeah, that looks right. But I've already looked at the test at Z and the p-value. I know those are right.
Which slide is this? Okay.
So I think we're up to 8, right?
Yes. I'll do the second one again.
Okay.
Do you want me to wait until I can share?
No, it's okay.
Okay.
You got 9, Jocelyn?
Yeah, I'm doing 9.
Okay, great.
Jocelyn, your p-value is not, I don't think we should reject HO.
Okay, so if it's lower than 0.05, we would not reject, right?
No, because in this problem, your what do you call it? Yours is 0.1. It's not 0.05 in this problem.
Oh, okay, I get you, I get you.
But you wouldn't
What is
reject
that symbol called?
the alpha.
The alpha symbol?
Yeah, that's the first Greek letter of the alphabet, the Greek alphabet. Um, but we wouldn't reject either way, would we? Because that p-value is not going to be lower than like any alpha you ever see, whether it be 0.05 or 0.1. P-value is not low, so the null doesn't have to go. We've got all this probability here represented by this area under the curve, which says that it's very possible for the sample data to be what it is, given a true null hypothesis. I mean, we're at 0.23, it's totally possible that we could just get these sample data, which are not very extreme. If we were going to have very extreme sample data, that would be very unlikely to happen. Same is true on 10, yeah. I mean, your p hat on number 10 is almost 0.25, it's 0.24, right?
Uh,
96 divided by 400, which is,
yes.
yeah, 0.24. That's almost the same thing as p null. So that's
So the p hat is the sample proportion, right?
right.
Okay.
And we got these data, which, yeah, they just pretty much go right along with the null. About a quarter of the people, or whatever the test is, whatever the individuals are. That's what we're getting. So we're definitely not rejecting the null. It looks right.
Jocelyn, your p-value isn't lower than 0.05. 0.05. 0.05 is the sample proportion, right?
Okay, so if it's lower than 0.05, we would not reject, right?
Jocelyn, your p-value isn't lower than 0.05. 0.05 is the sample proportion, right? Jocelyn, your p-value isn't lower than 0.05.
What do you mean?
Your p-value is 0.1360.
Sorry.
Mhm. A lot of times people have the question, let's see, 1.29. Because there was this whole thing about kind of not stats with tech, which is still used a lot of places. I mean, Kozak, is progressive about tech. And in a lot of courses, you have to remember that in a two-tailed test, to get the p-value, you have to double the area. But in the two main kinds of tech that we're using, which by the way could change because you might have seen that in some of the editions of Kozak, she uses this open source software called R, which I heard was not that easy to use, but now I'm hearing it is quite easy to use. So I might change if you in future semesters, not this one. But anyway, sometimes people see that and they say, well, should I double that p-value from 2 times the 0.136 and call it 2.272? Is that the real p-value? But no, the tech we're using, the calculator and StatCrunch, they just give you the right p-value with any doubling already having been done. Okay, so now let's go back to testing for mu.
Are those the same answers that we put on slide 7 or 6?
Well, not all the same. The second one is going to be the same. That's true. And yeah, and the third one's going to be the same also, but the first one is different. I'll just getting a oh, okay. I thought you were
Oops.
capturing your answer on slide 7 and you were just going to paste it on slide 2.
I can't on my
Oh.
iPad. I have trouble with that. Why do I keep messing up this symbol? Is T the population mean? Is that what it's asking?
No. It is a test stat for this kind of testing. I think this is 7.3.
Oh, okay. Oopsie, haven't started that one yet. But it's the same thing, right?
Well, it's similar in some ways. So, I mean, the formula for T is going to be in 7.3, but we're testing for now population mean mu, And
Mhm.
just to let you know the background, when I was taking this class, we were using Z as the test stat, but now no one does that. So that tells you how long ago that was. You weren't even born yet. So no, literally that's true. You were not born yet. So we were using Z for the test stat when testing for mu, but now everyone uses T. I shouldn't say everyone. Some people do use the under certain circumstances. And then you get into the old thing that where you've got, okay, is N at least 30, and is sigma known, and you have to look at all those criteria, and it's complicated. But now we just use T all the time for everything when testing for mu, which is a lot better. Jocelyn, have you gotten into 7.3?
No, I haven't.
Hypothesis test for one population mean, t-test, and it's phantoms again. You can see the hypotheses are about mu, the population mean, and the hypotheses kind of work the same way, with the nulls being the hypothesis of equality, and then the alternative is the hypothesis of some sort of inequality, either not equal to, strictly less than, or strictly greater than. You've got different kinds of assumptions here. We were just kind of talking about that. Random sample of size n is taken. The population is normally distributed. Or the sample size is at least 30 with no outliers. So, how fun is it to check that every time? If you are given data, you can use the methods from 6.4, which we didn't even do 6.4. So that was not even like part of the course. So don't worry about that. The population standard deviation sigma is unknown. So now if sigma is known, then you have authors like Blumen who would say, well, then you use Z at that point if sigma is known. And I have to give Blumen credit because his version of it is simpler than others. But the simplest of all is Kozak, which is just, we're just always going to use T. And we're going to assume we don't know sigma. And I asked Professor Newman at San Jac North, why he always has a t-test and he never does the z-test when testing for mu. And he says, it's because sigma is never known. In real life, no one ever knows the population standard deviation. I'm like, makes sense to me. So, we do that. Now he was using a different text and different, he wasn't using mom. And so what he had to do was select out the problems out of his course that used a Z test when testing for mu. But in Kozak, we never have that anyway. We always use a t-test. Well, there's something interesting at a moment like this. Name of the test is a t-test. Sample statistic and the test statistic The sample statistic for mu is X bar, the sample mean, which is the familiar X bar, number of successes divided by sample size n. And then test stat, T equals X bar minus mu null all over S over root n. Now it's very small there, so I'm going to write it again. T equals X bar minus mu null all over S over root n. Now that S over root n probably reminds you of sigma over root n from the central limit theorem. And yeah, that's what it is, except sigma is not known, so we're using the sample standard deviation S here. And so what we have is the common, form of a test stat, which is a sample statistic minus the population parameter all over the standard error. Obtain a p-value, and that job will be like when we were testing for p. At that point, everything is pretty much the same. We make a decision in the same way, state the conclusion in the same way. Everything after that is pretty much the same. One tail test. We don't know if it's left tail or right tail. We do know we've got a lot of area in the tail.
I don't know how to get this in StatCrunch.
Oh, okay.
Yeah, because I know for whenever we did the notes, didn't we have like a table with numbers? That's what I remember.
Right, exactly. So that's why I'm
So yeah,
like,
that's how
in
I
the
don't know what to
videos, they
put.
had
Yeah.
multiple numbers, so I don't know what to
Oh,
actually.
okay. All right. So yeah, let's
It's like I watched the video, but I haven't did the homework yet. So that's why I said I
Yeah.
haven't started on
yeah,
7.2.
sure.
Yeah, me too.
Okay, so we'll just talk about this. There's not much time left anyway, so we'll just run this both ways, and then that'll be it. Now, maybe we'll do the bottom one and peek at the rest. Maybe we'll just make the bottom one just so we um, maybe we'll visit this slide also before we call it a day. But yeah, let's look at the bottom one and because that way, I'll also be able to keep, save people from confusion and frustration about this whole thing about, for a two-tailed test to get the p-value, double the area. So here we've got this situation. It's a two-tailed test. So there's probability in both tails that add to 0.0684. Okay. Now, it could be that part of the difficulty in understanding this was that, how do you relate area and tails to p-value? Well, in a one-tailed test, they're exactly the same. Okay. But in a two-tailed test, it's the sum of the areas in the t-tailed, which in the tails, which is equal to the p-value. So that will be the 0.0684 divided by 2, which is 0.0342. Same in the left tail. P-value is, oh, my bad. Yeah, like saving everyone else in one point. It's the 0.0684. Oh no, that's the area in the tails. Oh, double the area. Okay, right. It's area in both tails, and that is the p-value, 0.0684. Zero point 0.0684, and reject H null. Depends on the level of significance. I think we're using alpha equals 0.08, 0.05. Which is kind of the default significance level. Okay, now, so actually, you didn't have to use any tech to get the p-value. Now, in slide 2 here, Jocelyn says, stat test 2 stat tests 2 t-test, and that is the right kind of t-test. You gotta be careful because there are different, t-tests. Yep. Yep, that's the one. And that's t-test for mu. You would think they make it part of the name of the test, but they don't. But what's good is they always let you know if it's for proportion. In StatCrunch, okay, so stat, and let's see, we did proportion stats to do that test. T stats, one sample, say with summary, yeah, sample mean, sample standard deviation. Sigma is not known, only the standard sample, the standard sample deviation, S is known, sample size, yeah. So there you go, Ajay, it's stat and T stats to run one of these tests for mu. Make sense? Make sense, Ajay?
Say it again.
It's
Sorry, my dogs are barking.
It's okay. So it's stat and T stats, and then one sample is that's what we're
Okay.
doing right now.
Okay.
Now, summary, that's more there are more problems for summary, but sometimes it's data, right? And you have to like put the data in as we have done before.
So with the problems on the class kick, how would I input that on StatCrunch?
Well, you don't do it for these problems. I mean, these are not really, you don't really do any.
Oh, okay. That's what I was confused about. Okay,
The whole point is mu reject or no reject. And it's reps on making that decision about, am I going to reject? Am I not going to reject? Right? Because if you have a p-value, which is related to the area, if you have the p-value, we're just assuming, oh, here that we're not assuming, we're being given an alpha. That wasn't there before, was it? Oh, it was there. Oh, alpha is 0.10. I just didn't see it.
But if we're not given alpha, we're assuming it's 0.05.
Yeah, that's the best assumption to make if you are required to do something involving alpha and you're not given alpha. So reject alpha this time, yes, because p-value is less than alpha. And so, yeah, all of this is just about those reps of making that decision, reject or no reject. P-value for a one-tail test, it's the same. But with this alpha, we're not going to reject, right, Jocelyn? Because p-value not less than, p-value is greater than alpha because the 0.015 is greater than the 0.01. Now, all this stuff about two-tail test, one-tail test, since we're not really finishing this in the meeting, I don't think you're ever going to have to worry about, for a two-tail test to get the p-value double the area, although it might have been in the video, the way you two are describing it. Basically, the calculator and StatCrunch, they just give you the right p-value. Now, I want to comment on this thing. Find the t-value such that the area in the right tail is 0.10 with 25 degrees of freedom. Okay, now, in general, degrees of freedom are either known or they're just the sample size minus 1 for the kind of testing we're doing right now. And area in the right tail is 0.1. And we want a value of t here. This is now a t distribution, which is kind of like z, and then in some ways not like z. It's a t distribution, and there's a value of t here. Now that's going to be positive. We can see it's to the right. So in that way, it's like z. T is actually a number of standard deviations from the mean. And to get the value of T in the calculator, let's see, it's going to be it's not this. Second bars is district. Okay. Now, we've used this before. We've used normal PDF and normal CDF, and that takes z-scores and gives you an area. Then there's inv norm, which takes an area and gives you a z-score. Now what we need is inv t, which takes an area and gives you a value of t. Now, if anyone's watching this and you're using the TI-83, the TI-83 does not have inv t. Okay, so if that's an issue, you either have to use a table or you have to kind of work the problem backwards to figure out what T is, which is a pain, but it can be done. Well, those are the only real ways to do it. So, but the 84 does have inv T. Now, I believe it wants, now I have to remember the arguments. I think it's got to have, what does it have to have? It has to have area, and I think it wants area in the left tail, and of course a number of degrees of freedom. Basically the information that's given right here. So let's see if I'm right on my memory for that. 25 degrees of freedom. And yeah, that's the kind of value of T that I expected. Something positive, but that is a lot of area, 0.1. So it's positive, but it's not, a big value of T like 3, 4, 5 or more. It's just 1.316, or I'll just say 1.32 for T. 1.32 is our value of T. And that's the answer there. And we had to use inv T to do it in the calculator. And we had to do a little math to figure out that it's 0.9 in the left tail. And so that's how to do it with the TI-84. Does that make sense, Jocelyn?
Yeah, I was gonna ask you, sorry. How do you for the MT, where was it again? To get the
Yeah,
iron.
second vars.
Oh, and the bars, second bars, yeah.
Yeah.
Okay. Okay.
Okay.
Yeah, I get it though.
Great. And for the calculator, or for StatCrunch, we'll end with this. This is where I rely on the user friendliness, which is pretty epic for StatCrunch, because I don't remember how to do this, how to do something like inv T. In StatCrunch.
Is it summary stats?
Oh yeah, it is going to be something because we don't have data. Stat. Did you find it?
No, I was saying like the summary stats like option, like after you goes to stat, do you do summary stat?
Yeah, I mean, that's the only possibility here. Sample size, I'm going to say 26 because the degrees of freedom were 25. Hypothesis test, okay. Oh, yeah, yeah. We get the full, hopefully this will have it somewhere and it could offer more than the TI-83. We get the forward, but not the backward. So I will look into this. I'm gonna dismiss here and look into this. And
That's what I was asking you. Do you go to summary stats?
oh, I see.
Or is it under calculators and normal? I think it's probably calculators and normal.
Well, it would need to be T, not normal. Oh,
Okay.
hey, look at
There we
that.
go. I think it's one of those buttons.
Yeah. Okay, so probability X less than or equal to let's see, it was 10% in the left tail. Let's go with that. And a 0.9 in the left tail. There it is.
Yeah.
There
Okay.
it is. Good job. All right, I get it done. So there's our value of T there, 1.32 approximately. So yeah, it was stat and summary stats. No, not summary
No,
stats.
calculators.
Calculators and
And
T.
then T.
Yeah, exactly. That's what there's our inf T right there. Have a great day.
You too. Thank you.
My pleasure.